I think that you'll have learned perceptron. What is a perceptron? Also, in today's lecture, we will be looking into uh, what implementation of a single perceptron. So basically, in today's class, we will be looking into how to implement a perceptron from the scratch, because nowadays we have these libraries like TensorFlow, PyTorch, which give us the inbuilt packages where we need not build it from the scratch. Everything happens by itself. We just have to mention how many layers are required. But in today's class, we will basically be looking into how to build a perceptron from a scratch. So, yeah,
Smriti, can I interrupt?
yeah, sure, sure.
So, I think before starting the sessions, I will give some brief idea about what is in 23rd. You assignment one will be released. So the major instructions regarding the assignment one, it is actually the individual assignment. It is not the group assignment. The major thing that we face for the individual assignments, it is actually the auto graded. So the naming for the file should be in proper format. Otherwise, we could not able to do the proper evaluation through the auto grader. So if you have everyone, every student will be having some student's ID, right? So the naming for the each of the file should be your student ID underscore assignment one dot ipynb file. So for example, if your ID is something 2025 AA 05 005 like that, you can consider. So if it is so, you have to follow the first you have to make your bits ID underscore assignment one IPY1. It should be the naming convention for your assignments. So all the instructions are there in the file which we will be planning to upload in assignment one. Please go through each of the instructions line by line before doing the things. So the major thing is that the naming convention, don't make any mistake on your naming convention. It should be your student ID underscore assignment one dot ipynb. If there is any mistake that you have made, then what can happen that you will get 0 mark for those assignment. Even though your codes, everything will be correct, and then you will be having 0 marks. And clear instructions are there for assignment one. We are uploading one instructions file, PDF file. So where you have to look into that, what are the steps is there, then how you have to take the data set, everything is there. So please look into that in details and before doing the things. Okay. So please try to stick on. Yes, yes, you are correct, Dheeraj. That is correct conventions. Yes, naming convention is correct, which is given by Dheeraj. So even though if you want, then I will give the instructions. So this is the file format. Your student ID underscore assignment one dot ipynb. Smriti, are you recording the things? Yes. Okay, fine.
Yes.
Then other thing is that. So you have to select a real world data set. Everything is there, and the data set should contain greater than 500 samples, and it should have as in between 10 to 15 features should be there. And then you have to the major agenda for assignment one. You have to implement a baseline linear model from the scratch. There is no SQL model should be used. So you have to implement the MLP from the scratch. So that is the basic agenda for assignment one. Anyway, we will upload all the instructions for the assignment one. It will be released on 23rd. So please wait for until regarding the assignment. So while you are uploading the during the submission, we are expecting two file. One file is in IPYNB, second file is in HTML extensions. So HTML extension, HTML version, and then both will be having the same naming conventions. So the 10 mark is there for the assignment. So you can follow. uppercase, lowercase, that is not an issue. You can follow anything. Just the first ID should be your bits ID. Then you
Is this
underscore assignment.
assignment one is group assignment, right?
No, no, no. It is actually
Individual. Okay.
individual.
Okay. Okay. It was asked by one of the student.
It's an individual assignment only. So then we will, yes, both IPANB and HTML you have to submit. So in order to get the output sometimes, so that's why we are planning to HTML. You can just the file, the similar IPYNB file. So if you want, we will upload one samples without any code and something like that. We will upload those also. Or one sample will be uploaded along with the assignment. Okay. So you can go through the assignment and then assignment instruction, which is clearly everything is there. You just follow the things. Okay. Okay. Thank you. Over to you, Shruti. So
Yeah.
we
Yeah.
will,
Thank
if
you,
you have
Samira.
any doubt, then you can message in the Taxila. Okay. So every instruction is there in the PDF files. I'm just because we have only 2 more days are there. So just because webinar is happening, that's why I just give the instructions. So please don't make any mistake on your naming conventions. Instruction, everything will be enabled on 23rd. Okay, please wait until that.
Yeah. So students will move ahead with the webinar. First, we will try to understand how to use the virtual lab, and then we will proceed with the coding. So I'll be sharing the screen. I hope my screen is visible. Could you all just give me a thumbs up if it's visible? Yeah, thank you. So we'll move ahead. So the first step will be you have to log into your Taxila portal. There you have to go to access courses and live lectures. That will be your first step. There under my courses, you will get your course. You can click on my courses, e-library, virtual lab, Viva or project. Here you will be going to my virtual labs. So under my virtual labs, you basically have to CSSIS connect to lab or CSIS lab user manual. So we go to CSIS connect to virtual lab. If you go to user manual, you'll just get a PPT on how to use the virtual lab. So once you are connected, so basically since I have already connected, it gives me this screen. If you are not connected, you'll have to first select the experiment, I mean the course. Now, for example, this is S225 NSP4 DNN. You will be selecting that and then you will be uh, launching. You will basically be launching. Since my uh, virtual machine is already launched, I will not be getting that option. I have launched my virtual machine. But if it is the first time for you, you have to select this and then you will have to launch. Please note that you will be getting a time limit of 22 hours for a virtual machine for your entire course, I believe that is. So since I have launched, I will basically be giving start. Also, whenever you are starting a virtual machine, you have to make sure you stop the virtual machine. Even if your code is executed and you don't stop, you just close the tab. What happens is your virtual machine will be running in the background. Your time will just be going. So always please remember, once you've executed your code, even if you close the tab, your virtual machine is still running in the background. So you will always have to stop your virtual machine. This will take around 2 to 3 minutes of time, student. So once I launch, I will be connecting it. So they are giving you a username and password. So basically the username and password is not required. You can log in without that. But at times what happens if you're just moving from tab to tab, at that particular time your virtual machine system might get locked. At that time when they ask password, you have to just enter. But generally you will not require this password. So the virtual machine is taking time to load. Students, I think there is an issue with the virtual machine. So I've just locally kept the code in my Jupyter notebook also. So if I'm able to log into the virtual machine to later, I'll just be showing this is the login process. And then another, you will be getting a virtual machine through which you can actually start executing your code. But I think there's some issue due to which we are not able to create a session. So for now, we'll just start the webinar where I have the code in my local system. So basically, we will be looking into a perceptron. So what do you understand by the word perceptron? A perceptron is nothing but just a single neuron. You just have a single neuron. I'll just show you. Whenever we talk about perceptron, it's just one single neuron. You have input layers. You just have one single neuron where all the computation is taking place. So the idea of this neural network was basically inspired by how our brain works. So initially when it started with a single perceptron. You just have one basic neuron which is going to do all the computation. So in today's class, we will basically be implementing three gates, that is AND gate, OR gate, and the XOR gate. Using our neurons. So whenever we talk about our neuron, how basically it is estimating or calculating the output, basically we use a function z is equals to wx plus b. So when you see this, x is nothing but the input. Weight is nothing but weight is initially 0. So input is nothing but the different features. For example, if I'm trying to find what can be the price of a house, or whether the student is going to pass the semester or no. Let me take that as an example. So the different input features can be number of study, number of hours the student is studying. Then the next feature can be number of hours the student is sleeping. The next feature can be number of classes the student is attending, whether the student is eating, whether the student is playing. So for example, I have 5 features. Might be the feature where the student is sitting and studying. Number of hours is basically affecting whether I will pass or no the highest. So that feature will be given the highest weight. And whether the student is eating or no, that is not much concern. It is very indirectly related. So that will be given the lowest weights. So the weights basically tell which feature is basically having more importance. So that is basically your weights. Next one is your activation function. Your activation function is basically having, like, once all the inputs have come, here we are basically using a very basic activation function. So if the value is greater than 0, then the value will be 1. That is, he will pass. If the value is less than 0. So that means he is basically going to fall. Any value which is greater or equal to 0, that means he's going to pass. That is basically your activation function. The next one is basically your cost. Your cost is nothing but it will calculate how close. For example, I am trying to tell whether this student is going to pass or fail. But my neuron is predicting that the student is failing. But in actual, that student is going to pass. So there is an error. So whenever there is an error, we use this formula to recalculate it and push it closer to the actual value. Next one. Whenever we calculate the error, for example, the student should pass. That the student has failed. At that particular time, what happens? The weight which is basically assigned is not correct. Every time the weight has to be updated. So this is the formula. That is nothing but old weight. As students, we'll just finish this, then we'll go to questions, okay? Old weight minus alpha. Alpha is nothing but a learning rate. Learning rate is a small numerical value which is basically being considered. Then sigma I is equals to 1 to m is nothing but I'm calculating weight for all the rows. AI is nothing but the value which is predicted. YI is nothing but the old value. XI is nothing but the input value bias. So whenever we are calculating the weight, can you see this formula? Zi is equals to weight into the input feature plus B. B is nothing but the bias. Bias is a small value which is added to make sure that we don't incline to zero value, or we are not very inclined down to add some more weight and push the value up. Bias is basically added. So I think you'll have doubts. I'll just take the doubt and I'll start ahead with the coding. So basically what happens, it time runs out. So your resources are only assigned to 22 hours. After that, you will not be getting the resources. Can we pause the time if away from the screen? Yes. So whenever you start an instance, this time starts running. Till you stop the instance, it is always being um, running. So whenever you want to, you cannot pause, but you have to stop the instance. So the virtual machine is nothing but a system which is always running in the background, students. Even if you're not actively using, like for example, now we are having a conversation, the system is actively using. But what happens once I start my virtual machine in the background, it is active. It is actually running. So you will always have to stop it. So I'm just showing you need not do the lab simultaneously with me. So in your virtual machine, you can just open the terminal, type Jupyter Notebook and run your IPYNB file. That works, but I don't know, there's some glitch due to which it's not working. Y'all can just follow what I'm telling. These files will be shared with y'all. Y'all can follow it. The first webinar is not on DNN. DNN is deep neural network when you'll have multiple neurons. Today we are just looking into one neuron. Okay, I'll switch off the video. I think students are having network issues. Um, so the J function, everything we will be uh, following once we start running the code. I just want to know how many of you all are very new to Python. Could you all just raise your hand if you all are very new to Python? Okay, fine then. Okay, thank you. Then we will, I'll just go it, I will run the first code in order and then I will start explaining what is function. I should, just a minute, I'll share my screen. Yeah, I hope my screen is visible, students. So, yeah. So in, here we are basically trying to define different functions. So can you all see define, initialize size, define, initialize parameters? These are called as functions. So what basically happens in Python when you want to run something again and again, instead of writing that each and every time, you write them as functions. So what happens, just if you call initial size and pass the parameter, you can be able to run all the code inside that. So basically that is the role of functions. So in today's code, we are basically trying to implement your OR gate, AND gate, and your XOR gate. So the first part of the code, import NumPy as NP. So whenever you are dealing with matrix, matrix operations are very well performed in pandas and NumPy. So here you are using NumPy because you have a lot of matrix operations which will be happening. So import matplot.py plot as PLT and import matplotlib are same, but pyplot is nothing but matplotlib is a very big library, and under that pyplot is nothing but a small part. So instead of using this, you can just directly give the import matplotlib. That works. And matplotlib inline is nothing but you are trying to display it in the Jupyter notebook only. So in today's class, our input X. So basically, whenever you're talking in terms of neural networks, your input is basically said to be as your features, input features or independent variables. Your output is basically said to be as your target variable or a dependent feature. So X I will be talking as input feature in today's class, and Y will nothing be but your target variable, which is nothing but the output. So in today's class, we are basically first implementing your OR gate. So as we all know, your OR basically has combination 0, 0, 0, 1, 1, 0, 1, 1. The output for 0, 0 is nothing but 0, which is given as minus 1. For the remaining 0, 1, 1, 0, 1, 1, the output is 1, 1, 1. This is something which we are aware of. Next, we are calling something called as visualize xy. So your visualize xy is nothing but a function. So whenever you call visualize xy, we look for the function. It searches for the function visualize xy. So it goes here. So visualize xy. What is your x? Your x is nothing but this. And your y is nothing but these values. So when you call visualize xy, it goes for that particular function. So in visualize XY, you're basically defining two colors, red and blue. So basically you're defining two colors, red and blue. Next, you're telling label y dot flatten. So what happens when you're defining y, you're basically defining 0, 0 for minus 1, 0, 1 for 1. It is basically not a 1D array. It is not a 1D array. So when you use, how will you know 1D array is nothing but whenever your input is given like 1 comma 1, 2 comma 3 comma 4, this is basically your 1D array. So what basically you want to do, whenever you want to print it, you want it plotted as a graph, you basically want it as a 1D array. That is why you are basically using flatten. Next, what I am doing, I am taking x of dot comma 0. Whenever you are using x of dot comma 0, again we'll go back to your input, x of dot comma 0. So this is x which basically has 0, 0, 0, 1, 1, 0, 1, 1. So basically whenever you are giving, it is basically in the combination of 4 rows, 2 columns. So what I'm trying to tell here is nothing but x of dot dot means I want all the rows, and here 0 means I want only my first column. So what I'm basically passing here, x of all the rows comma only my first column, and in the second part I'm basically passing all the rows and the first column. Alpha is basically used to tell that, I mean, sorry, I'm here students. Alpha is basically used to tell The transparency alpha value is basically used to tell the transparency. If it is 1, it is not at all transparent. If it is 0, it is not visible. So it is basically used to tell your transparency. So C is nothing but labels. It is trying to display your labels, whatever labels are there. Then here I'm trying to get this colors. So basically this colors, what is there, I am basically giving that value to CMAP. So why I'm doing this, I will tell you. Then I'm giving the title as scatter plot, X label as X1, Y label as 1, X ticks as 0 to 1. So this is basically this graph, students. Whatever I'm plotting is this graph. X1 is here, X2 is here. So we basically are getting, we are plotting at 0, 0, we are plotting it as red because we are telling that red, and we are basically giving the value also as blue. Since we are giving as CMAP value, it gives the negative value as red and the positive value as blue. Since I am giving it as in CMAP matplot.colors.listed color map, that is why it is differentiating the different colors. So when you'll see 0, 0, which is basically a negative value, it is getting 0, and the remaining things, which is nothing but 0, 1, 1, 0, and 1, 1 having positive values. And if you all see here, you basically have X1, which is label X1, Y1, ticks is 0 to 1. It is basically having 0 to 1. Here Y label is also 0 to 1. So all that whatever we wrote in this part is basically just to plot this graph. So whenever I call the function visualize X comma Y, it goes to that function and it is basically plotting this graph. Then next I am plotting print before training. So what happens? It is just printing before training. After that, I am calling another function initialize X comma Y. So for initialize X comma Y, what I do, I'll have to again look for the function initialize X comma Y. So in initialize X comma Y, what I'm passing, again, I'm passing the input variable that is nothing but 0, 0, 0, 1, 1, 0, 1, 1, and Y is nothing but minus 1, 1, 1, 1. So next what I am doing, I am taking nx is equals to x dot shape. So what is my x dot shape? It is basically 4, 2. That is nothing but number of rows, columns. But here I am giving nx only the number of columns because those are your input features. Here you basically have two input features. That is why I am passing 4, 2. Similarly, for my ny, that is nothing but I have 4 rows and 1 column. That is basically my ny. So I'm creating a dictionary with size. So basically dictionary is a data type in Python which basically has key value pairs as its input. So what basically happens, size is equals to nx basically gets the value from here. Here it is 4, 2 here. So this gets the value 2 and ny is basically 4, 1. So basically this gets the value 1. Nx is assigned with 2, ny is assigned with 1. And what happens whenever I'm returning the value, the function again, once this executes, the control is again passed to where I got it from. So basically this was what was my initialize x comma y. Next what I am doing is I'm just printing the size of x. Then next what I'm doing, I'm calling the parameter initialize parameter size. So I'm passing size. What my again size has? It basically has what value is returned. That is nothing but it has nx comma ny. That is basically there in your size. So what is my nx value? That is basically nothing but 2 comma 1. So what I'm passing here, my size basically has this value 2 comma 1, which I'm passing. After this, I will take your charts. Okay. Initialize parameter. I'm calling a, a function which is initialize parameter, and I'm passing this value 2 comma 1. So this is initialize parameter. Size of x is nothing but 2. Size of y is 1. The same value is being appended here. Weight is equals to np dot 0. So initially we don't know which input feature is important. So we will be giving that value as 0. So bias is equals to np dot 0 is ny comma 1. Students, based on how many outputs are there, you will have so many bias. So here you just have one output. That is nothing but whether based on your XOR input, whether it is 0 or 1. So based on that, you're basically predicting the output. That is why your bias is, you have only one bias, and that is also 0. So your parameters is nothing but weight and bias, which is initially nothing but 0. So that you are again passing it here. You're basically printing your weight and bias. Initially your weight and bias is basically 0. You can see that this size, that is nx, is basically 2 and ny is basically 1. Shape is basically, ma'am, can you please explain scatter plot again? Where are all x values and y values? So this is basically my x value 0, 0, 0, 1, 1, 0, 1, 1. So the same thing is coming in the scatter plot. So when you're taking your scatter plot, this is basically by x value. I'm giving it as the first row of the first column of x and the second column of x. That is what I am giving here. So based on that, it is basically getting this 0, 0, 0, 1, 1, 0, 1, 1. Yes, you can get the code. Yes, yes, yes. It is for everyone. Yeah, sorry, students. I just closed the meeting itself. So I will continue. So what we did is just the basic setup. That is nothing but we gave the input. We set the weights. We set the bias initially to 0. So here, this part is very important, student. So this part is important where we are basically using the forward propagation. So in forward propagation, here we are basically learning. Oh, sorry, my screen is not shared. Sorry, sorry, sorry. I'll share. I hope my screen is visible now. Yeah. So this part is very important, students, where you will actually be learning how to basically build a single neuron. So x and y is nothing but the input. Here we all know x is nothing but 0, 0, 0, 1, 1, 0, 1, 1. And here you are basically trying to classify whether the output is 0 or 1. And weight is nothing but initially it is 0, as we all know. And uh, and then your this one, your iterations, how many times it should run is nothing but 100. That is nothing but how many times it should run. So your weights basically contain the weights, also the bias, both are 0. And here 100 is nothing but iterations, how many times it should run. So students, generally what happens, in since this is a single neuron, we are mentioning it to be as 100, but actually what happens in your, as you move ahead with deep neural network, you have something called as forward propagation and backward propagation. that is basically said to be as an epoch. Here you cannot use the word epoch because you don't have one forward propagation and one backward propagation makes an epoch. But here, since we are just having the value as 100, we are just running it 100 times till we get the value. But what happens sometimes, within, you need not run it 100 times, might be within 10 times, 11 times you are getting the value. But since here we are implementing a basic neuron, we will be running it 100 times. 100 times the same thing is run again and again. So what is the function name here? Forward propagation. So we will go to the function forward propagation. So this is your forward propagation. X and Y is nothing but the input. Parameter is nothing but your bias and the weights, and iteration value is nothing but 100. Learning rate. So learning rate is equals to 0.1. Always a learning rate is a variable where you will be taking the value as small as possible. But the value shouldn't be very, very small that it will take time to converge, or it shouldn't be too large that you will just spend time getting lost. So it should be a small value. So it can be based on trial and error method. So down the lane, you will understand why it should be small enough, because you will be learning the concept of gradient descent, but you should understand it shouldn't be very small and it shouldn't be very large. Cost history is nothing but it will be it is a list where so whenever it is a square bracket, it is basically a list. So a list is nothing but cost history will basically be when you're running each time, like 1, 2, 3, 4 iteration, it will be basically be storing like how much of it is deviated from the actual truth. Next one is w. W is nothing but the weight. P is nothing but the bias. M is nothing but x dot shape of 0. It is taking nothing but the shape of x. So now we are running a for loop from 1 to iterations. Basically means 100 means it will run 99 times. So it is basically running from 1 to 99. Z is equals to np dot x comma w plus b. So whenever you are trying to find an output, it basically takes this function. So x into w plus bias. So for example, here initially our value, for example, our first x value is 1. So it will take 1 plus, so here we have two inputs, for example, student, we will take the first input. So our first input is 1 comma 0. Our x value is 1 comma 0. So this will be when you apply z is equals to, it will basically be 1 into 0 plus 0. If it is just one value, if it is just 1, it will be like this. Okay. So what basically it is telling, it is taking value is 1 comma 0. So it is basically so this is x1, that is nothing but 1. 0 is nothing but the weight, that is w1. Again, your x2 is nothing but 0 and w2 is nothing but weight, that is w2. So when you are taking x, for example, when you are taking your x, that is nothing but 0, 0, 0, 1, 1, 0, 1, 1. So whenever you are calculating, this is the formula, w1 x1 plus w. You are taking the bias to be as 0, then the bias keeps changing. So since you are calculating this, the value of this will basically be 0. So z is nothing but 0. 1 into 0 is 0 plus 0 into 0 is 0 plus bias is 0. Next, what you will do, you will be using this as your activation function. So np dot sine n. So what basically happens here, if it is a positive value, it will take the value as 1. If it is a negative value as 0, it will basically take it as 0. So this is how it will work. Next, you are calculating the product. Why you are calculating the product is, For example, A. If A is 0 and you are multiplicating it with y is nothing but the value. So what happens, students? This basically becomes, sorry, not this basically becomes, gives 1 minus 1 or 1. It doesn't give 0. Okay, sign Z gives minus 1 to y. If the value is less than 0, it gives us minus 1. If it is 0 or greater than 0, it gives us 1. So what basically happens when you are multiplying y with a? For example, your actual value is 1 and your predicted value is 1. So your output will be a positive value. If you have your actual value is 1 and you are predicting minus 1, your value will be as negative. So what you're trying to tell, if your value is always correct, if your value is correct, this will basic your product will be positive. If your prediction is not matching the actual value, then your product will be a negative value. So what basically happens, maximum is equals to np dot maximum product comma 0. So whenever your actual value is correct, then your product will be returned. If your actual value is wrong, then your 0 will be returned. So your maximum basically gives the actual value whenever your prediction is correct. It returns 0 whenever your prediction is not correct, because it will be a negative value. So your cost is basically used to try to understand your cost. If it is the lesser the cost, the closer you are um, to your actual value. So this is basically used to calculate the cost. Students, here I am using minus 1 by m. Minus 1 by m is not necessary. You can just use 1 by m. Here minus 1 by m is just used whenever you are trying to maximize some value. You basically use minus 1. Based on your application, you will use it. NP dot squeeze cost is basically used to get it in the form of 1D array. Here you had created a list cost history, right? So you will be appending it to that. So this is my first iteration. This will be running 100 times. So what happens now? Since my cost is high and I'm not actually reaching the actual value, I will be updating my W. Whenever my cost is greater or equal to 0, I will be updating the weight. Weight is equals to learning rate. Learning rate is nothing but your 0.1 divided by 2 star np dot of x transpose. Why you will be transposing x is nothing but to get it in the form of a column matrix, comma a minus y. Again, this is a and y is your actual value. And bias is nothing but b minus learning rate divided by 2 np dot sum. And then you will be storing this a cost history, w b for each iteration you will be storing this. So this is how it will be happening, and this will run 100 times for the entire x. That is nothing but 0 0 1 0 1 1 1 0. It will run 100 times and then it will be returning the value here. After the training, what basically happens, the cache value which is returned, that is a, w and b, you are basically displaying here. Initially your weight was 0 and 0. Your weight which is being displayed is nothing but 0.1 and 0.1. This is the weight which was calculated. Initially your bias was 0 and here bias is nothing but minus 0.05. Your y is nothing but minus 1, 1, 1, 1. A is nothing but the output which is received from the neuron, that is nothing but minus 1, 1, 1, 1, which is exactly the same. Uh, I hope till here it is clear. We will look into plotting of graph, cost function, and then I will take up your questions. Next one is your decision boundary. You're calling the decision boundary function. Your decision boundary is nothing but it is taking the parameters, that is a, w and b. So again, your decision is taking nothing but your x, which is nothing but 0, the first column, second column. Alpha is nothing but to take the bold. C is y dot flatten. C is nothing but the actual value which is there. Y that is nothing but the actual value. cmap.plot.cm.rainbow is nothing but I am taking the inbuilt function and I'm giving that to my color map. N is equals to 20. So what basically happens here? I want this line to be drawn. So I'm telling that I need 20 lines for it to draw this. So I'm giving n is equals to 20. Next, I am telling x is equals to line space from minus 0.1 to plus 1. Use 20 lines for it to draw. Then I'm taking y is equals to minus np dot x comma w of 0 divided by w of 1. That is weight of 0 divided by weight of 1 plus bias divided by weight of 1. So I'm using this formula basically to draw this line. That is the mathematical formula which is basically being used. Then I'm plotting that line x comma y. X is nothing but the 20 line, y is nothing but the formula to get the straight line, and then I am basically using the green color for it. And here, as you all know, red is nothing but your positive value and blue is your negative value. Students, since I am able to draw a straight line where my positive values are this side of the straight line and my negative value is this side of the straight line, it is basically said to be as a linearly separable equation where I'm linearly able to separate my positive lines and my negative lines. Next is the cost function. I am basically calling the plot cost result. I'm basically calling my cost function. Your cost function is nothing but it is taking the history, that is cost history, where we were basically saving it here, cost history. It is just taking that and it is just displaying that. So what basically happens? I'm running 100 iterations. Initially, my error was high or the cost was high, and then it came down and then it remained constant. So if you'll see here, you can see within 5 or 6, it is the error is completely decreased. But since I have given 100 iterations, it will be running 100 number of times. Just take if you all have any questions. So what is y dot flatten? So what basically happens, your y is not a 1D array. Flatten makes it as 1D array. Could you explain 4 comma 2 and 4 comma 1? So my input, which is nothing but this is 4 rows, 1, 2, 3, 4. This is 4 rows. So this is 4 comma 2. Here I have one row, that is 1 and 4. I mean, this has to be like this, students. Now this is basically 4 rows, 1 column. That is nothing but 4 comma 1. Initialize is nothing but I am just giving like how many X has how many columns, Y has how many columns. I'm initially giving my weights and bias to 0. Time 100 is flat and everything. Actually, your 100 learning rate is not required, as I told. In your advanced classes, you have some built-in function like early stop in deep neural network, which you can use. But since this is a small neuron, I have given as 100. You can give it as 0, 1. Yes, output should be 1, 1, minus 1 based on your input. Yes, all the data will be, all these will be shared. So students, in your second example, we will be looking into your AND gate. Your AND gate is 1 just for 1, 1. For the remaining things, it is 0. So here you'll understand why we define functions. So we will be calling the function visualize, where it is basically plotting the 3 negative values and 1 positive values. We need not write the code again. Again, we are using initial size. where it goes, the control moves to initial size here. And then it is just giving like what is X shape, Y shape, and it is returning the shape. So all these functions are automatically running. You need not run it again and again. So is this and? Yeah. And then you're initializing the weights. Initially, the weights will be 0, 0. Again, you're calling the forward propagation function where you are actually initializing XY weights, the neurons, and then you are estimating the weights. So when you see initially again here, the weights and bias are 0. But after running your iterations 100 times, you can see that your weights are 0, 0.0, 0, 0.0, and your bias is minus 0.5. And then again, after that, you are training. After training, you're getting that value. Again, you are plotting a graph. Students, since again you see the positive values are here and the negative value is here. Since you are able to split the positive and the negative value, it is said to be as a linearly separable value. And here the cost function, you can see for the first three values, it fell down, then it increased, again it dropped down, and then it remained the constant. So this is again for AND gate. For XOR gate, again my same inputs, but when you see for XOR gate, when it is 0, 0 and 1, 1, the values are 0. For the remaining things, it is 1, 1. We are calling the XOR function visualize. So you have two positive and two negative values. Again, you are basically taking the weights. The same things are happening. You are taking the weights as W and 0. If you see, before training, you're giving the weights as minus 1, and bias as 0. If you all see here, your XOR weight is minus NP of ones and bias is minus NP ones. Students, you need not give, this is just to show that you can change the weights this way. Initially, people do consider the weights as 0, but if you want, you can give different weights taking minus NP of 0 and bias as minus NP weight of 1. So initially the weights are minus 1, and your bias is minus 1. Also, after training, if you all see here, the output for XOR gate is 1, 1, 1, 1. But if you see the value, the output is actually minus 1, 1, 1, minus 1. This is very important for you all to understand, students. Since the data is not linearly separable, in your previous cases, you all could see that your data was like the positive values were in one side and the negative values were in one side. But in your XOR, you cannot bring the positive values to one side and the negative values to one side. That is why you say that your XOR value is not cannot be implemented using a single neuron or a single perceptron. Your XOR cannot be implemented. And also you can see that the error is very, very high. So basically your XOR data, if you see, it cannot be implemented using your single perceptron. Your AND gate can be implemented, your OR gate can be implemented because they are linearly separable. That is, each class, like positive will be in one side and the negative will be in one side. But your XOR, it is not possible. Since we have input and output parameters, can we calculate one or two iterations in each of AND? Yes, you can use 2 or 3 iterations, but you see in the XOR, you will not get the output even if you run it for 100 iterations, because using a single perceptron, you cannot use it as a linearly separable data. Can you see the XOR cost function? It is going up and down, but we are not getting it to 0 or very less. So this was the first topic of your webinar. We will look into the second topic very quickly. That is nothing but linear regression. So before we move on to linear regression, it is very important for you to understand um, what is the regression. So you basically have two types. One is classification, one is regression. Classification is nothing but when you tell cat and dog, you will be able to differentiate between cat and dog. It is classification. Pass and fail, it is basically classification. But when you talk about regression, regression is nothing but when you want to tell the temperature, when you want to tell whether that particular what to tell, whether the temperature, the marks of a student, whether what is the price of the house, where the numbers are continuous and it keeps changing. That is basically where regression can be used. So when you see, you basically have importing functions like numpy pandas. These are basically used for mathematical vectorized matrix operation. Matplot library is basically used to plot matrix. Train test split is basically used to divide the data, which we will see. sklearn dot pre-processing import scalar is basically used to import the data. Standard scalar is nothing but whenever you want to bring the data between 0 and 1, we use the inbuilt function, which is scalar. We will understand how it is working, students. So I think you'll understood function. So I will not be going function by function. Instead, I will go from the beginning of the code because you all will be able to map the functions. So the first function is define load auto mpmg, where I'm taking the data from this URL, that is nothing but your machine learning database auto mpg.url. If you put this URL in the browser, you will get the data. And I'm defining the column names as mpg, cylinders, displacement, horsepower. I'm giving the variable df is equals to pd.reach.csv. That is nothing but the URL is the CSV file. Each column will get the name, that is mpg cylinder by column name, and the columns are decided based on the separator, that is based on the white spaces which are there. The column is basically decided. Na dot values, Na dot values is nothing but question mark. Whenever there is an empty column, it basically gets a nan value. And slash tab is basically whenever there is a tab space, it basically becomes comments. df is equals to df dot drop na. Whatever basically is empty column that was replaced by nan value here, all those values we are basically dropping. Then I basically have another column called as car name. Since it is not useful, I will basically be dropping car name, and access is equals to 1 is basically I'm trying to tell drop that entire row. Next, I am giving print is equals to star 80. So this is equal to sign. If I want to print is equal to is equal to is equal to is equal to 80 times, instead of writing it 80 times, I'm basically giving it as is equals to star 80. Then I'm printing auto mpg. Then is equals to star 80. Again, I'm printing print data shape df dot shape. That is nothing but I am telling that how many rows and how many columns are there. Df dot shape. Df dot column to list is nothing but all these column names I want it as a list. Then I want to see the first few rows. If I want to print the first few rows, I give df dot head. And if I want to understand like what is the median 25% of the data, I basically give df dot describe. So what is the function name, students? It is load auto mpg data. So here you can see I am basically using this df is equals to load auto mpg data. Whenever I use load auto mpg data, it is basically giving that I have 392 rows, 8 columns. These are all the features. Then when I give dot head, it is giving me the first few rows. And this is the statistic. Dot describe will basically give you the how many rows are there, the mean, the median of each column or each feature which is there. I hope I'm clear. Any doubts? Students, we'll have to finish this webinar, this topic in half an hour. So I'll be a bit faster in this part since we've understood what is a single neuron. So I think this is clear. In the second function, what happens? Once I have defined my data set, next what I am doing, I am taking x dot df dot drop mpg axis is equals to dot values. So what I'm trying to do, out of the entire data set, I am dropping mpg and giving all these as the input features or my training data x input features. So all these will be my x is equals to input features. Next, what I'm doing, y is equals to df mpg dot values. So my mpg is basically going to be my target data. That is basically my target data. That is what I am doing here. Then what I am doing, feature names is equals to df dot drop mpg axis is equals to 1 column dot to list. So what I'm basically doing, I'm basically displaying all my input features name other than mpg fuel c. All the other things are my input features. Next, what I'm basically doing, I am basically looking into my data preparation. So if you see, you're basically seeing your data preparation. Next, what I am doing, whenever we are using our input data, we basically have to have our training data and our test data. Our training data is nothing but from where I will be learning. So based on the training data, my input, my model is going to learn. And my test data is basically used to validate whether my model is learned correctly or no. So basically here I have 80% of my data, which is said to be as my training data. So here, since I've given test size is 20, the remaining 80% of the data is basically used as my training data, and the remaining 20% of the data is basically used as my testing data. And the random is equals to 42 is basically setting a constant test data. So what happens today, you're running this model. After a few days, you again want to rerun this model. So if your test data keeps varying, might be your output data or your output keeps changing. So in order to keep the constant in order to keep a constant test data size, you basically will be using random is equals to 42. And then you are basically printing the test data size and the train data size. That is nothing but you have 313 rows of test data, and you have 79 rows of your you have 79 rows of your test data, and you have 392 of your train data. Next, you are doing scalar. So basically what scalar is nothing but you are trying to bring the values 0 to 1. When you see these values, this is like 18, this is 8, this is 307, this is 130, this is 350, and this is 12. Whenever you have data which is varying, you basically want to bring the data from 0 to 1. That is why you use the scalar function. Why you bring the value 0 to 1 is nothing but whenever one value is high, like this is in thousands and this is in a single digit value, this might be given a higher weightage. In order to keep the values constant and not to give any higher weightage, you basically bring the values 0 to 1. So how you do this is nothing but you basically will be using the function I think it's not mentioned here, students. Yeah, you can see here xj is nothing but that particular input value minus mu j. Mu j is nothing but the mean of the entire value divided by sigma j. Sigma j is nothing but the median. So it is x minus the mean value divided by the median value. So if you are using your scalar function, it is automatically being done. Your scalar is an input library which is automatically being done, which is nothing but the input value minus mean divided by the median. Next, you are doing x scaled is equals to scalar dot fit transform. Fit transform is basically done to that x scaled value. You are getting the scale. You're applying the fit transform function to the extrain data, and you are scaling all the values to 0 to 1. Next, you see the transform functions. Here you're fitting like the mean value, the median value is you're trying to get it. Here you are just using transform and not fit transform because you want the same x-train values, mean and median, to be reflecting here. If you are trying to get in x-test scaled also mean and median, that might go wrong because your x-train is what your machine is learning. Based on that, only the test data should come. Please note, whatever your machine is learning, the same thing should be applied to your X test scale. You cannot be using the different mean and median here. Yes, it is standard deviation. So standard, whenever you are bringing the value to 0 to 1, your standard scalar will always use X minus the mean divided by median. So there are different ways of achieving it, but in this case, one example is x minus mean divided by median, but you can achieve it in different ways. You have different ways of standard scalar. It is in common terms, it is said to be as data normalization. I think you all have heard it about data normalization. So your standard scalar is nothing but your data normalization. I hope this is clear. So here what you are basically doing, you're loading the data. You are, after loading the data, you are basically setting the input value, that is anything other than MPG is nothing but the input data. The next part is your Y value, that is nothing but the target data. Then you are dividing the data into train and test data. 80% of your data is nothing but your training data, which is assigned to X train and X test. So your X train is nothing but all these features. Other than MPG, what features are there? And X test is nothing but the MPG value. So your data keeps on learning. That for example, if I take for if the student is learning for 5 hours and attending all the classes, he is going to get 80 marks. So based on that, your training data. So based on the ground truth, here the learning is basically happening. And your Y train and Y test is nothing but after the learning has happened, you're basically validating how correct your model is basically learned. So that is why to validate how well it is learned, you're basically using Y train, Y test. Random is nothing but you are trying to understand how you're trying to keep the test data constant. That is nothing but today you are running, again after 5 days you are running, the same test data should get in. So this is basically to get the same test result, or to reproduce the same model, you basically used random 42. Random is equals to 42 need not be 42. Initially in the textbook the value 42 was used, that is why 42 is basically used in most of the cases. You can take it as 0, 1, 2, 3, whatever you desire. And standard scalar, as I told, is basically used to normalize the values. It is basically used why to normalize the values so that one particular value does not get the higher importance. That is why your standard scalar is used. I hope till here it is clear. Any doubts? Any doubts, or shall I move ahead, students? Yes. Next, we will look into our next function, which is nothing but your single neuron regressor. So what basically happens? After this, you want to train the model. So to train the model, you basically will be calling the function single neuron regressor. Your learning rate is 0.001 and you're running it for 1,000 iterations. So that is what basically is happening. So when you are basically running single neuron regressor, your function call is basically passed to your single neuron regressor. Student, here one very important thing what I want to tell you here is, here I'm basically using something called as class. Class is basically used because whenever I want to store the values and I want to move ahead, if it is basically it has multiple other functions in it, you basically will be using class. Whenever we learned perceptron, we just used functions, but here I'm using it as class because multiple other functions are basically defined in it. That is why I basically define this as class. Init is basically when you want to initialize itself. Self it is calling itself. Learning rate is already defined as 0.01. Iterations is 1000. Seed values 42, which is already defined. And the same thing is passed here. Weights and bias is none, which is basically 0. And self dot history is nothing but the cost function which we learn in a single perceptron. It is again a single, a square bracket. Student, here weight and bias is basically 0. And the same function is basically used np dot, the same function whenever a neuron is there, it is x is equals to w1 x1 plus bias. The same function is basically used for all the input features, or the input features what are there. Z is basically being calculated and it is basically being returned. Compute loss. Students, this is something which is very different. Here we are basically using something which is called as MSE. Here, mean squared error. So here you're basically using mean squared error to calculate the loss function. So in the previous case, we didn't have a particular loss function. We were using the product and all. Here we are using the cost function, and one of the cost function which we are using is the mean square error. So your mean square error formula is y minus y cap is nothing but your predicted value minus your actual value, the whole square. Your whole square is basically used in order to remove the negative value. Whenever it is like -2, if you square it, it becomes 4. That is why you're basically using your whole square. Sigma I is equals to 1 to n. You're applying MSE for all the rows which are there. Divided by 1 by n is nothing but you're taking average of all the rows. You're just taking it for all the rows. Here 2 is basically used because whenever your MSE was calculated, basically your derivative, the math behind is this, you're calculating the derivative. So that is why this 2 comes here. So there's math behind it, 1 by 2, which will be taught in your theory classes. That is why it is actual MSE formula is just y cap minus yi. Since you all have multiple rows, it is nothing but sigma I is equals to 1 by n, y cap minus yi, and you have n, which is divided in total. So that is basically used as a loss function. So the more the loss, the more the error. That is what you understand. So compute gradient. Student, here your learning rate is actually something which is basically very important. So what happens, your gradient, so you'll have different ways of calculating your ways to update your weight and bias. In your inbuilt machine learning, deep learning models, your gradient is basically used. In your previous case, we were manually calculating, but your gradients are actually the right way of calculating. So the formula for gradient is nothing but 1 by n np dot x dot transpose of errors. Why you're transposing it is nothing but whenever it is row format, to do the matrix multiplication, it becomes difficult. That is why you are taking it in your column format. Next, what we are doing, we are trying to fit. So always what happens, your fit is basically used once your model is learned. It is basically your fit function which calls the model again and again. So here you are basically having n comma n features is equals to x dot shape. So n features is nothing but your number of features, that is number of columns, and x is nothing but the number of rows. So you're basically giving the same number of iterations, self dot predict x. So here what happens, y predict is equals to your x of test, whatever test data is there, that I'm passing here and I am predicting, and it is computing loss. So whatever y predict is nothing but the prediction, and y is the actual value, and it is predicting the loss. And once the loss is predicted, student, each time the loss is predicted, the gradient values are computed again and again. So until and unless your loss is 0, the gradient values are computing itself again and again. I hope this is understood, this formula. This is nothing but self weights this is nothing but self weights minus self learning rate into gradient weight. So instead of giving self weight minus learning rate, I give it as self weights minus is equals to self into learning rate. So this is the formula of gradients, which is basically used whenever your error is high. This formula is applied and your weights and biases updated. So next you have this verbose. This verbose is nothing but whenever you want to display each loss like that, like this, you basically use something called as verbose. Your verbose for each iteration, like I don't want to print for each iteration, I want to print for each 100 iteration. So that is why I'm giving iteration is equals to 100 for each iteration. 100th iteration you print, or you print it for the last but one iteration. So if I give 0 to, if I want 100 iteration, 99 will be my last iteration. That is why I'm telling for the last iteration, for each 100th iteration or for the last iteration you print. So since I have 1000 iteration, it is printing for 0, 100, 200, 300, 400 till 999. It is printing. So that is what your verbose does. Next, what I'm telling, the iteration number and the loss. So this is your iteration number. So 0th iteration, 100, 200, 300, it is printing, and loss. Can you all see for the initial loss, it is 310. And as your weights are updating, as your weights and your um, as your weights are updating, if you can see, your weights are updating and your bias are updating, your loss is basically being decremented. That is what is basically happening here. Your loss is also decreasing. So that is what is happening. And dot 4D is basically used for your 4-digit number, students. It is basically a 4D. So if verbose is mentioned, I will be running it till my training is completed. So I will be running it till my training is completed, and whatever is my final loss, I will be displaying it. After that, what I am doing, student, one important thing, you have to understand what is model. So people talk about deep learning network, they talk about different things, but they don't understand what is model. Your model is nothing but once my data is being trained, I get a best set of my weights, I get my best bias. So whatever is basically retained, the last final best weights and the final bias what is there, that basically is my model. Now when I call model dot fit, what happens, it does not undergo training again and again. When my model dot fit is called, it just goes to this fit function. It just goes to this fit function and it just computes the losses. Please note, once your training is over, you need not train the model again and again. The best combination of weights are already there. So every time you call model dot fit function, you are just passing your X data there, and then it already has the trained model. It just does the prediction for whatever training data is there. So now here I'm showing, see, model dot predict. I'm just passing the X values. So once I pass the X values, what basically happens? I get the Y train values. So then what I do, I am comparing my Y train with my Y predict. Now I already have my prediction. I have to evaluate my prediction. For that, what I basically will be doing, I will basically be using my error metrics. For classification problems, you have different error metrics. For your regression problem, you have different error metrics, that MSE, RMSE, MAE, and R square. That is nothing but your MSE. That is nothing but your mean square error. Whenever you are using your MSc students, you should be sure that when your data is sensitive to outliers, your MSc will be high. Next one is root mean square error. It is same as RMSC, but you're taking root of MSC. So what basically happens, when the value looks very huge, your root will decrease the values, and it basically is very easy to understand. Mean absolute error is used whenever you have lot of outliers. It is less sensitive to outliers. That is why you use mean absolute error. R square is basically used to tell the variance. If R square is equals to 1, that means your prediction is perfect. If R square is equals to 0, that means your model is okay, or it is not predicting good. I mean, it's not okay, it is not good. If it is negative, your model is very, very bad. So that is what it means. So whenever we are computing, for my train values, I'm getting MSE of 11, RMSE of 3.3, MAE of 2.5, R square of 0.8, which is good. Next, what I do, I am passing my X-tail test scale data. Your X-tail test scale data is nothing but your X test data, which is basically used to validate your model. Whenever you're passing this model, it basically is giving 11.62, which is comparable, 3.40, which is comparable, 2.5. Whenever your training and your test data are similar or comparable, you tell your data is, your prediction is correct. If your training data is very good and if your test data is very, very poor, you basically tell that your model is overfitting or underfitting. Overfitting and underfitting, overfitting happens when you give too much of details and your model is not able to learn, and underfitting happens when you're not at all giving any information. So here, when both are closely related, that you tell that your model is learned well. In compute gradient, we need to sum all errors, but we do errors. Y pred minus, is this running in single iteration? So in every iteration, you will basically be computing y pred minus y true. So for each column, you will be checking. So for gradient descent students, what basically happens, there are different types of gradient descents. If you're taking gradient descent, it will take the entire data set, what we are taking. If you are taking mini batch gradient descent, it will take batch by batch, might be it'll take 10 rows at a time. So it depends on how you are giving, but in what we are giving, it is taking the entire data set and it is computing the errors. Yes, you will be getting such questions in your midsem exams also, or you will be getting a case study where you will be given a problem statement and you will have to give like what type of gradient descent is used. Like in theory classes, you will be learning different types of gradient descent. So you can give like what type of gradient descent will be much suitable for the problem, or how you compute the error, or how is MSC computed, all that will be given. Code will be given. Um, that is not possible here. Split screen option is not possible. So I have to be moving towards the screen. Yes, you will have to use Python to do with students. The entire code need not be done, but yeah, some part of the code will be expected for you to write. Any more questions? Like what part? I didn't get that. Yeah, that's what I told, right? They will be like a case study will be given, and you will might have to write like not a complete code from the scratch, but you might be having like a snippet type, like how many neurons are required. Entire code will not be given. The entire code need not be given. From the scratch, you need not give the entire Python code, but for your assignment, you will have to write the entire. It's exam will be online, right? You have to go to centers and write. Semantic errors like in students, your EC2, your assignments, you're talking about, is it? For your EC2 and EC3, your EC2 and EC3 is your. So it depends on the problem. You need not give everything, but the syntax is required. We will not be expecting like the code which I showed. But based on the questions, you can. Assignments codes like this will be expected, students. Please make sure you will follow the complete instruction as it is given, and you will move ahead. Otherwise, what will happen is the assignment will not be considered. So you'll have to follow. We will be sharing a sample. Please follow it as it is. You will be getting the assignment instructions very soon. Students, I think we will end. Any doubt regarding your exams and your assignment, we will be sharing the snippet, code snippet for your assignments, and exam will be discussed by your faculties in your regular classes. Thank you. I think it was too much of rush for the second code. And since it's very early for you all to understand, as your theory classes are proceeding, you will be able to understand this in a much better way. So even if you all have not understood much, that is okay for in today's class. Files will be shared. Files will be shared, students. I'll stop the recording, and I think we can disconnect. Thank you, students. Thank you.